Okay, so we're going to look at Lisp, and I've already given you a tour of Lisp, and you've started on your implementation, so you understand Lisp to some degree there. And if we were to just look at, programming in Lisp, that introduction I gave was probably enough for you to go to the Common Lisp manual and go and understand how Lisp works. Okay. So what's going to be different in what I'm going to talk about is that I'm going to actually talk about implementation. Okay, we're done with Let's. That's one of the extra credit things, and that you should be able to do now after this. And I think in 25 minutes I can do the last part, but we'll see. So I'm going to put my software engineering hat on. Right now we are looking at we're just trying to be cute with Lisp, right? And see all the things we can do. And last time Ruben said, oh, should we really use function versus lambda? And I said, it's up to you. I'm giving you a nice, interesting, nice toy, and you play with it as you want to, because in Lisp we only play. You want to do serious programming, this is my bias is coming in. You use a language that is safer. So let's go in, and I was implying software engineering principles. So I created all these, we did motivate this stuff through software engineering principles. Okay. So we motivated FUNCALL by giving you two different display results that had common code. The only difference was that the operator being applied. In both cases, they say the result is, the lambda says the result is. In one case, it says the result is of plus xy. In the other case, it says the result is of star. Okay, so we went and defined a new display result that took the operator as an argument. Okay, and we said, okay, we'll just do print FUNCALL fxy. Okay, so this allows reuse. If I go and change the result is to the capital R result is, I have to change only one piece of code. I don't have to change multiple pieces of code. It may not save you typing, as I keep saying, but it makes sure that things keep consistent. Okay, so far so good. We've been good. We are having fun, with functional arguments, and we are following software engineering principles that I would also advocate in a real language, a language that's real to me. Okay, so far so good. So then I went and showed that this is separation of concerns. That not only can I vary the model, the computation, plus or product, but I can also change the output format. Okay, so I've got display result and I've got display result 2. One of them uses one kind of format for the output. The other one uses another kind of format. Okay, so I'm just trying to show you that it's separation of model and view, if you will. Okay. So far so good. Now let's go and look at this code critically. I did not think very much when I was creating this code. Okay. In retrospect, you might say deliberately, because I can now motivate something else, but I really wasn't. So let's look at this critically in 2 dimensions. First, let's go and not change the structure, and let's just look at the way I named things. If I was to say, you get points for naming, I'm being good. I'm not saying F1 and F2. Okay, so I'm saying display result 2, but there's some ways in which I could do better in terms of explaining the code. So if you were a TA for 110, and you were told, find some, just like police have often told, go and find some speeding drivers. Okay, let's make some money in the county. If you were told, okay, get some points out. Okay, I'm a victim to this. The first program I wrote in this country, I used the word I twice in 2 loops, and I lost 10 points for each use of I from the TA. I haven't forgiven the TA still. Okay, so if you were that kind of TA, and you needed to find fault, what might you find fault here? Okay, you guys are good. I've often put code in 110 and 401 like class and said, find problems. And it's amazing how many problems people find. So sorry, can I see with the hands up? Who hasn't? One, two, okay. Three of you have, okay, who should I give? You haven't said enough. Okay. Ja-
I guess display result is kind of telling me it's just going to give me the result. Doesn't tell me it's going to give me a pre-sentence beforehand or anything like that.
So just tell me how to fix it too. So what should I do?
Display result with preceding sentence.
Okay. So and what about the next one?
Well, the next one doesn't tell me that it's any different. I think like what is the result going to change?
Display result is result 2.
Yeah.
I have to remember which is, firstly I have to remember it's 1 and it's not 1, it's display result, and then it's 2. I mean, that's confusing, right? And then how am I distinguished between the two display results? They're both display results. How do we know what's different? Why would somebody use one and not the other? Right? You say tough, just figure it out. Okay? But anyway, what was your problem going to be?
I was just going to say you could name them differently so that it's more like the difference between the two, because I'm not sure why.
So you're saying that the name is not giving enough information, but you're not quite sure how to name it differently.
Well, like, I don't necessarily know, like, why you would want to use one over the other.
Okay. So we don't quite know why you would use one over the other, right?
Yeah.
But what do you think? I mean, I just put some garbage there as far as I was concerned. But from a user's point of view, one is more,
Consumer versus
sorry?
one's for the end consumer versus
So you're saying that, which is for the end consumer?
the result is
The result is more verbose, right? Now, some people like verbose, some people are succinct. Okay? So maybe we should use the word verbose and succinct. I mean, this is serious, guys. You know, otherwise nobody will ever remember what, if you really are have written some very complicated piece of code that you want people to use, and people don't know when to use it, you might as well not have written the code. Anything else?
I guess I would, if I'm really nitpicking here, I would question why these are even, like, why have two of these?
Okay, so that we've decided. Why I needed it? I needed to show some facility thing. Okay? And it's very hard to come up with nice, succinct examples that are also motivated. That's one of the biggest challenges when you teach. Okay? And in this class, I've been going more for succinctness, just because functional programming is all about succinctness. And rather than going for, you know, when I do 401, you know, I have to show so many lines of code, and then people can't understand that very quick. You can't even scan it in a class. Anything else I could improve on? What if I want to change how I'm being succinct or I'm being verbose?
Can you just pass the sentence as a parameter?
Sorry?
Can you just pass the sentence as a parameter?
So you're going 2 steps before, you're going 2 steps ahead. Okay? So that's, so I'm saying I don't want to change the structure here. But we'll go to that next. Yeah. Sorry, doesn't compile? No, hang on. This matches with this. This matches with this. Sorry?
The second one.
Oh. No. According to my own rules, in assignment, in exam, I said if the code doesn't compile, if it's not pure Lisp node, you lost a lot of points. But I told you that parentheses will be forgiven. Okay, because that's a mistake I make. Okay, so it's my motor skills. When I try to copy, I just miss the left paren. Okay, that happens to me a lot. So thank you. But you know, what else can we do to sort of allow the verboseness and the succinctness to change? What if I want to make it capital R later rather than result? I want to really test your memory or your imagination. Okay. So anything else you guys can? Yeah. So again, please don't change the code right now. Okay? Don't change the structure of the code, just the naming things. Okay? So just this part. Naming is one issue. How else can you make something self-explanatory? Sorry? So I can make it naming. Naming can be one aspect. What else can we do? Anybody who's done a 401 has cursed me for sort of forcing them to do a few things, especially when you're doing geometry. So could I not do, I've got the strings directly in there. Okay, yeah. What, you gonna raise your hand? Yeah, no. Oh, yeah, it's okay. Like I said, you guys. How about using some named constants? Really? Doesn't this whole become clearer now? The short explanation, the long explanation? And I can't even type. You guys can type, so this is much more of a headache for me than you guys. Okay? So in general, all the declarations come at the start. And those are the things people might want to parameterize. And you do want to create, when you go to industry, I'm sure people, in fact, I'm doing actually an evaluation with a student. We're looking at all the successful GitHub code and seeing what style principles people really follow. And we're trying to go and correlate them with bugs. The theory is that you follow more style principles, the fewer bugs you might have had during the project. And I don't think anybody's tried to prove that. So we are just going in, and that's something that a student called Yi Cheng and I are look at. So, we can try to answer the question whether it's overkill or not.
I mean, it's like in some cases, no, this is not overkill. In some cases, I think in this specific example, it is. But like having.
But does it hurt in any way? By the way, it doesn't hurt. Okay. Now, if you ever seen COBOL programs, which you probably have never heard of COBOL also, and I have never dealt with a COBOL program, but COBOL was known to be verbose. Okay, so there is an argument of saying that, look, I had to go and scan this whole long outward explanation before, just tell me what the thing is. Okay, but anyway, I needed to sort of kind of do this, okay, to get my examples going. So okay. Now let's go and figure out how to go and refactor the code. And Rosh gave an argument. What did you say we could do better? How could we do better? Look at the commonality between the two codes. There's still FUNCALL, display, F, X, and Y. The only thing that differs is this particular different is these two things, right? So what could we do? Modules have 4-parameter function. A display that takes explanation as an argument, and if you don't want to go and provide that argument again and again, define a new function in terms of the previous function that goes and fixes the value of the argument. You want to fix 2 arguments, you go and create, I should have gone and put this box around product also, the bottom box around product also. You have 2 arguments. Okay? So this is arguably a better solution, which a lot of people don't do, by the way. Parameterization is something people often resist also. Okay. So far, so good? Okay. Again, this box should have gone around product also. Okay. So let's look at the people who resist typing. Okay. So, and this, by the way, I was at a conference. This is a big problem in API designs. Do you parameterize the API a lot, or do you fix the parameters? And people think it's a either-or thing, whereas it doesn't have to be either-or. You can have both cases. But I was at a conference, there's some CMU guys that did some study, and they said that's a big issue when people design APIs. And the reason why they weren't considering both things was it's a pain to go and write the first one and then go and write the second one too and the third one too, especially if most people are going to use maybe the third one. Okay? So let's go and try to reduce the pain somehow. Okay? And that's what's going to motivate the next construct we're getting to. So far, it's all software engineering. We haven't learned anything new. We could do programming like this in C. Let's go and exploit what we've learned in Lisp and functional programming to do something better. So how could I reduce the effort in writing the other two functions? I've got the first function with 4 parameters. I want to create the other two functions that take fewer parameters so that my users don't have to type so much and make mistakes in applying parameter values. Could I have generated, we know there's homoiconicity in Lisp. Could I have generated from the first definition the second two definitions rather than writing them explicitly? Something briefer than this. And so I want a generator. So what is the commonality between the two reusing derived functions? I want to go and somehow make their generation also more efficient and remove the duplication too. So what, if just in English, what's the commonality there? They both do funcalls. Anything else? They go and call display, right? And they provide the arguments. So we know that, so I'm saying generate from the first definition the other two definitions. So that's what they do. And how do they differ? So one provides an extra parameter, and both can choose what parameters to provide, right? So that's a similarity, that's a difference. So how to generate the lambdas from reuse function? So I want to find a new operator. And that operator is going to be a generator of functions from other functions. Okay, so now this is very interesting. We are not passing functions as arguments to other functions. We're defining a new operator that takes as input an existing function and generates the lambda for another function based on some parameters of this operator. Okay, and it can be, and those parameters can determine whether you generate the first lambda or generate the second lambda. So now you're an API designer, you've taken programming languages, you've implemented this stuff. You tell me what that operator parameter should be. We know one of the parameters of that thing is display. Okay? We know that we're generating from a function, and we know the output is going to be a lambda expression. Okay? Tell me what other parameters can I give to this particular operator so that I can distinguish between the first lambda and the second lambda and create many other lambdas that are related. Chris? So I can give n. So what should I give in the first case? I should give the number 3. So some number to indicate some integer value to indicate the difference in number of arguments. Okay, good. We didn't need that information for sure. What else should I give? Is that enough to go and generate the FUNCALL? So, yeah, Andrew?
We need to, give it how to, what it needs to do, what operations has to do with each of the different parameters.
So hang on. The operation is F, right? Display. That's the operation. So that we've already given. So we know that it's going to call display. So I can generate FUNCALL display from that. Right? I think I've got a slide on that. Anyway, but anyway, so FUNCALL display I can generate. Chris said number of arguments. Okay, but is that sufficient? What else do I need? Arguments. The actual values. Right? So how long will this list of arguments be? If the function display takes n arguments, okay, how long can this list of arguments be? N, at most n. Okay, that's it. So I can generate just from display the FUNCALL display and FUNCALL display here. If I just gave display as an argument, I can generate the FUNCALL display. Now I go to generate short output explanation followed by fxy, or short output explanation followed by product. Right? So I go and decide this is my argument. Okay, so I give this particular thing that I want an argument, this list of arguments I want supplied to this operator. And if I do that, I can generate the short output explanation. And then how do I know what to put after that? I provided one argument. This function takes 4 arguments. So once I know what an argument is, I know this argument, how do I decide that there's fxy here?
This is generating with just like return, would it then like want to return that display result parameter that you're partially creating?
So yeah, that's what I want to return. I want to return these lambdas. How does it know to put fxy here? It's got display as an argument, it's got short output explanation as an argument. That's all that we've given it so far. What can it do to generate fxy here? And what are these fxy's? Where do the values of these variables come from? So I'm generating from one function another function. I'm generating from one parameterized function another parameterized function. Right? We know in the body of the function we're going to have FUNCALL, function name, and some supplied arguments. I have to make 2 decisions right now, which are related. What are the parameters of this lambda? And what are the unspecified variables in this FUNCALL? Okay? So if I know display, what can I do with display? I can look up its lambda, find all its arguments, right? I know one argument has been specified. So fxy just happens to be the remaining arguments. Right? We know that display takes explanation f, x, and y. The first argument has been supplied. So I create a new function that takes as parameters the remaining arguments, and I go and make those remaining arguments, I put those remaining arguments in the FUNCALL. So I can actually generate both of these parts by knowing what is in display and just supplying the remaining arguments. So I'm essentially what I'm doing is I'm partially applying an existing function with n parameters and creating another function with less than n parameters based on how many parameters are supplied. And in the other case, I go and give product and short output explanation as an argument. And it says, oh, I got the first 2 parameters. The other 2 parameters are unspecified. So let's go and create this function with 2 parameters and supply these parameters as values. Okay, let's just, it took me a long time to make this animation, as you can imagine. But let's just go and show this. I want to generate this function, right? I just say curry. I told you there's this curry, Haskell Curry was somebody who programmed a lot. So Haskell was used to name a language and curry was used to name the operator. So I just say curry display short output explanation and I get lambda fxy, funcall display short output explanation xy. And if I want to get this lambda out, lambda xy, funcall display short product, what should I do? How should I call curry? See, you're getting used to it. Lets you have your cake and eat it too. You can define your parameterized, heavily parameterized function and then derive
So, is this effectively sort of an automatic let that returns lambda? Like, it automatically like associates the values of the first however many, and then just returns the lambda.
That's one way to look at it. That it's a leg that's generated. It's actually a lambda.
Right. It returns lambda, but like it associates those in a new space.
Yeah. It's basically binding the values. And there's many ways to do it. You can try to create a new environment, but we're just hardwiring it into the lambda expression. So we are deriving, if I was to do ML, you guys are waiting for other languages. ML does a lot of this stuff. I mean, when I studied ML, this is when I first saw Curry. I saw Curry first. So this is, by the way, you can't do this in Common Lisp. Okay? So this is something, you're going beyond Common Lisp here when you implement this. So I wanted to put things that are not in Lisp also in our Lisp so that you understand those concepts. So this is something that comes from ML. At least I saw it first. Okay. But even if you don't really implement this, use it, it helps you understand things that you might go and take a function that's got so many parameters and create another function that has got fewer parameters, and this formalizes that. Questions? Okay, so your assignment 3. And we can, of course, take the curried lambda and do a set Q on it. Okay? And then use the curried lambda in a funcall. Okay? Because what's this curry operation going to do? Curry is going to return a lambda that you assign to a operation name. And then you're just going and doing a funcall after that. Okay? So again, going back to the assignment, curry happens to be an extra curried part in your current assignment. I couldn't finish all the discussion. I didn't show you the implementation. If you guys have enough time, implement it. And your checks that you have been given, test for curry, but we will move those checks to assignment 4. Okay? So that you can implement it properly and get credit for it in the next assignment. Okay? Okay, so again, next Tuesday I won't be here. And enjoy your evening today. So in assignment 3, I put in currying stuff, but we couldn't finish it, so that goes to assignment 4. And we'll hopefully finish that today and more. So to motivate currying, we looked at these two functions, display result long and display result short, and they both had a funcall which was very similar, and to sort of reduce the duplication there. Okay, this is the suggestion Roche gave last time. We went and added an extra argument explanation, which sort of took the material, took the printed out value as a parameter, and so we could reuse our original function. Okay, so we could go and then just give this particular value as a parameter and get our reuse. Okay, so we wanted to be a little bit more greedy after that. We've got this 4-parameter function display. Okay, and display result short and display result display star result short are both essentially calling this function with different parameters. Okay, one's calling it with one function takes 3 parameters, another function takes 2 parameters, and the one that takes 2 parameters hardwires the function, and the one that takes 3 parameters doesn't hardwire that, but both of these calls actually hardwire the explanation. Okay, so that's where we were last time, a week ago. I'm also building my cache here. So won't it be nice if this duplication in the second 2 functions could be somehow removed? Okay, in both cases we're doing a lambda, we're doing FUNCALLs. Sure, the lambdas take different lists of parameters. The FUNCALLs provide slightly different parameters. But wouldn't it be nice if we could somehow, remove the reuse, remove the duplication and have reuse? Okay, and we said, wouldn't it be nice if we could generate the lambdas from the reused function itself? So we would have an interpreter provided operation, and that's the curry operation we saw last time, that would generate this lambda and generate this lambda. Without us having to write these lambdas down, it would generate these lambdas. Okay? And the whole idea of returning functions, as it turns out, when do you really need them? In later languages, it's in situations like this that they believe you really need them. Okay? So in Lisp, you can return arbitrary lambdas. In other languages, you use this interpreter provided operator, which is called curry. In ML, that's what happens. Okay, so this is an important operator. It's less general than Lisp, but it may, for practical needs, be enough. Okay, so the question is, how did this thing get generated? It can't get generated. This operator doesn't know about display, so somehow it generated these functions based on some information that we provided. So it is provided with the function that we want to generate, that we want to use. Okay. So we provide a function to this as an argument. It can generate FUNCALL to that function, okay, in both of these cases. So in the generated function, we have a FUNCALL to some function, and that function is taken as a parameter to this operator. Okay. Now these 2 FUNCALLs are different, so we have to somehow account for their differences. So we then also provide a list of parameters of this function that we want to hardwire. In this case, we have short output operation. In the other, and so based on that, it can say, okay, these are the ones you hardwired. Whatever you did not hardwire must be parameters of your function, and must be parameters that I go and just provide to this original function that from which we are deriving things. So xy must be a parameter, fxy must be a parameter to the lambda I'm generating, and fxy parameter must just be passed to this function display from which I'm generating this function. Okay? And similarly, in this case, we have a list of 2 parameters. So we have fixed 2 of them. That means 2 are left. Okay? So those are the 2 that we'll declare in the lambda, and those are the 2 we will pass along. Okay? So that's the general idea, and that operator is called curry. Okay? And we see it being used right now. So we defined our display with 4 parameters, and we are now going and creating new functions out of display that basically supply one or more of the actual arguments this particular function display needs. Okay? So in one case, I say curry display short circuit explanation, and the other case, I say curry display short output explanation product. Okay? 2 different lists of actual parameters I'm supplying, and as a result, I get 2 different functions one that takes 2 parameters and one that takes 3 parameters. Okay? Questions so far? And like I said, in ML, as far as I know, curry is the only way you can use, curry is the only operator to return a function. Okay, you don't just generate arbitrary lambdas. You want to return a function, you take some existing function, you curry it, and you get back a return function. Okay, so this is a typical use of return functions. Okay, so this seems to be complete, but it's not. There's lots of holes in this definition, and we need to know how it's implemented. But before we do that, of course, we can take a curried function and associate that with a name. Okay, that's all I'm doing here. So I'm doing the same thing. I'm currying twice. I've got 2 curries, and one curry I'm assigning to curry display short, result short, and one I'm assigning to curry display product result short. Okay. Okay. Any questions so far? Let's do more reuse. Can we reuse the currying that we did? We've done 2 curryings here. Can one curry reuse the currying? You reuse another curry. Is there enough similarity there that we could somehow reuse the work we did in one currying in the other curry? So one curry is curry display short output explanation. The other is curry display short output explanation product. They both have a common prefix.
What happens, like, what happens if you call that function before the asterisk?
Okay, so what happens if I do what? If I call this function?
Yeah.
Where?
Like, what happens if you call that?
So here I'm showing you how a curry's function is called, just as normal. FUNCALL curried display result short 2, 3. So that's just a, you just call the lambda, you just use the lambda because lambda got assigned there, right? So whenever we do a FUNCALL, we go and do an eval of that. That eval will return the lambda. That will get used. Andrew?
So since we're just adding product onto curry display short result, could we just call curry short display result and then add product to it?
So you just do cascaded currying? Yeah. Okay, that's kind of what you were hinting at. Yeah.
So you couldn't just call that alone?
Yeah. Yeah. So we've got this commonality. So we can go and do setQ. We've got this already, right? And I can do now twice curried display result short, which is basically currying the curried result. Okay. So I told you last time that there's all these issues with, should you have multiple parameters? Should you hardwire the parameters? And here you can just go and gradually reduce the number of parameters in a function. Okay. So things just compose, which is what we want. Okay, questions? And then I can just call it just as before and get the same result. Yeah.
Is curry kind of like that in the sense that it takes the static or it takes the initial function and it kind of like creates it with localized column that has the parameters stored onto it, so then when it's called.
So that's what Robert said last time, that it's like a let, that you're actually binding the values, but you're getting back a function. Let just gives you an expression result. Here you're saying, look, I want to bind the values and the unbound values I want to use for a. So let is a good old scope in Java or Pascal or some other language. That's kind of boring because it's good old. This is cool. That is saying, look, I'm taking a function, I'm doing something more structured. In my let, I'm calling a function. and I'm supplying some of the parameters of the function, return me back another function in which the unbound parameters, in which the of the called function are my parameters. So it's a very structured way of doing it. I mean, it's like having, you guys probably don't even know about it, gotos, which is what I used in Fortran when I learned Fortran. And then you go and replace them, and say, hey, let's go and have an if statement, let's have a while statement, let's have a do statement, so for statement. So it's just structuring things. As we understand better what we are doing, we go and have constructs that reflect what we're doing. So the general constructs are flexible, but they don't capture a particular situation as well and describe it as well. Okay, we still haven't quite figured out what curry means. And here's sort of an issue here. So we said, look, curry display short output explanation is lambda fxy, FUNCALL display short explanation fxy. Now look very carefully at the generated lambda and tell me, try to find faults with it now. You guys are good at that. And the faults have to do with scoping. So I've generated a lambda. In that lambda are some names. Display, short output explanation, f and x and y. F, x and y are parameters. Let's look at the name short output explanation. That name has to be looked up in some environment. The way which environment will it be looked up in when I go and actually do the FUNCALL of curry? Yeah. The environment that exists at the calling point, right? And will that environment always be the environment in which the curry was displayed, was defined? No? I saw you shake your head. Yeah. So I have now, you said curried function is sort of like let. Well, let's try to combine these two things together. So let's do the curry in a let. Okay? And that let can define new variables. So this let has defined its own short output explanation, which is not result but out. Right? And when I go and evaluate, when I go and call this generated curry lambda function, after that let has returned its value and assigned it to the curry display result short, which environment will it be evaluated in? The global environment or the let environment when I call the function? I've assigned to a global variable called curry display result short the result of a let. That let returned a function. Before returning the function, it went and defined a variable that overrode the variable, that global variable. Now, when I go and call that function, it will be in the global environment, and that environment will be, so at that point, which display result will be used? This is a lambda. Global. This is a lambda. This is not a function definition. We did not go and store the defining environment there. And so it'll be the global one. And is that what we want? That's a judgment call. But probably that's not what we want. And so it'll not be, it'll be this result, this particular variable that will be used. So this is dynamic scoping, free variable absorbed in calling environment, we got a lambda. And so how should we solve this problem? Supposing we want static, we want defining environment. What should we do in a generated lambda?
Use function.
Sorry?
Function keyword.
We can use the function keyword, okay? But we do want other variables. We do want the functionality of lambda and function both, and you know, we other variables we may want to be bound in the lambda. Okay, the curried function we may want. So the thing is, the right answer is to give both options. Okay? But that gets too, you know, we have to have a curry function, curry lambda. So that gets to be a bit much. So we could use function to and have all the parameters bound there, rather than just the curried ones. What else could we do? Yeah.
Or you can create an environment for curry object, like what we did for function object.
We could create an environment for curry object like we did for function object, but it's a little different. If you think about it, that's not quite going to work. Because on top of that environment, we go and we create a new scope. Here we want this to be, and then we put, you know, there's one level. Here we'll have to have another level now. We'll have one level for the supplied arguments and one for the unsupplied arguments. Okay, and that will create problems. So normally when you call a function which takes 5 parameters, all 5 parameters are defined in the same scope. Here we'll have some scopes, some parameters that are in one scope, and then its child scope will have the supplied argument. So that's going to create problems. Okay, if you just trace through your code, it's not quite going to work. There's a third alternative also that we could use, which is the one Andrew used, which I actually thought of that exact solution that you were thinking of, and then I realized it wouldn't quite work. Yeah.
When you curry, you just save it in
So-
the lambda. Like you extend the lambda to save the value, and then when you call it, you pop that on.
So this is what Robert is saying is what one would do in Java-like language. Just evaluate the argument while currying, and save it in the lambda. Okay. So I do something like this. Actually, it should be out here, right? So, so we evaluate the argument, and in this case, it should be out rather than result. Okay, so I said FUNCALL display, and evaluated the short output explanation, and I go and put in the evaluated value there. Make sense? So this is not going to quite work. But let's go along with this idea of putting the stored value there. Can you think of a reason why this is not, you shouldn't go and put out directly there, you should put something else there? So we are evaluating arguments and currying scope to support static scoping. So that's almost good. But think about evaluating it. What's going to happen when I do a FUNCALL display? Will that argument be evaluated again? Will that evaluated argument be evaluated again in a FUNCALL? You guys have done FUNCALLs. So you got a double evaluation. And in case of an atom, it doesn't make a difference. But if I had something like this, quote, 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 out, okay, we first do an evaluation and get quote out. We put that in. Then when we do the FUNCALL, we again do an evaluation and get out. Whereas the intended result was, intent was that the curried, what we evaluated when we did the currying, the value we supplied should be the one that is used as the argument. We don't really expect another evaluation. Okay, I mean, that's what we assume the intention is. That I'm evaluating the argument, and it's that evaluated argument that is going to be used, that's going to be passed to the function, not another evaluation of that argument. Nathan?
I don't know if I'm not understanding what's happening, but like, so what you're saying Curry does is it can actually quote the input so that when it tries to FUNCALL it, it automatically evals it because that's what FUNCALL does. So
Okay. Okay.
the desired output is the
Okay, so I think what you just said was the solution I'm looking for. The problem, so were you giving me the solution or giving me the problem?
I think so. I just don't. I'm not
But do you see the problem, the way I've stated it so far?
think this is the solution.
Yeah, so that's the solution. The problem is that we end up doing two evals.
Okay.
One when we go and create the curried function, and one when we call the curried function. And the intent is that when we curry something, the intent is that, look, I'm giving you an evaluated argument, and don't evaluate it again, please. Okay? So as long as we had that variable name there, that was fine, because then it would get evaluated once during the FUNCALLs. Now we replace the variable name with a value, and so the suggestion that you got, so let me ask, can somebody else paraphrase what Nathan said as a solution? Oh, you create another variable and store it in that? Okay, that's something. And what happens if somebody else has that variable name in it? Sorry, a special name. I'll show you what happens in Java. They try to use certain special names, and if you happen to use that name in your program, Java suddenly starts complaining, and you don't understand why it's complaining, because it's going to go and generate something else with that name. But what was Nathan's solution? That's a little better. You don't have to go and store just put it in a variable. Andrew? So you just put a quote around it. Okay. You evaluate it, and then you quote it after that. So that the next evaluation will give you back what the original intention. Okay?
And that solution would work no matter what the inner function is, right? You just have to set the root first.
Yeah, it will work no matter what. Yeah, because you're just doing a quote, and you're just saying that will take care of the extra evaluation. Okay. Okay. So you can see now this is what really happens. So that's exactly what you said. You know, not only are we quoting results, we're also quoting the lambda that the product was standing for. Okay, and that's also important. Okay. Questions? Okay, are we still fine, or is there something else that we have to fix along these lines? Along the scoping lines. Do I still have any names there that may cause problems? In the generated lambda? FUNCALL what? That's the name. what if the currying is being done in a let, that redefined display? Right? Now, just like the other name, that display will be looked up in the global environment when it is used, not in the defining environment. Right? And the answer to this? Evaluate it, get back a lambda, and do we need to quote that lambda? So let's go and show you the code. So I'm now doing FUNCALL of now not the name but lambda. We know we can do FUNCALLs on lambdas directly. Okay, so I evaluated f, I put the lambda in, and I don't have to quote that. I mean, lambdas, that's FUNCALL, the first argument is a lambda, and your evaluator will just handle that directly. Okay. Questions? Okay. So let's just be a little clear what we did here. And let's go and see the changes. You suggested, yeah.
Yeah. So, what is sort of more fundamental to what Quote's doing here? Like, effectively, we don't want to, when we curry away, we don't want to evaluate atoms, we want to evaluate X expressions, but then we have to evaluate it again when it's called. Is that what we're trying to get at? So why don't you just do that? I guess is the question. Like, why don't you just say, if this is an atom, I don't evaluate it. If this is not an atom, I do evaluate it on the when you curry it.
So when you curry, you can pass any expression, right?
Right.
You can pass any expression, not just variable names.
Right. Yeah.
And what we're trying to do is, we could try to go to the function root, and I'm going to sort of show you the function root is going to give you a different answer. So we end up evaluating it once when currying, and evaluating it a second time when calling the function. And we want it evaluated only once, and yet we want to store it in the lambda. So we want to have the two constraints. We want to store it in the lambda, the evaluated value, and yet we don't want it evaluated twice. So if we are not going to change our FUNCALL to do something funny, that's saying, okay, is this a curried function? If it's a curried function, I don't do this. If I don't change my FUNCALL, I have to do this. I could go and do I could go and put a little label in my variable saying this is a curried name, in which case I don't evaluate it the second time. So per your first suggestion, we are going to evaluate it while doing the curry.
Sort of, sorry, one higher level. So do we want it, I understand like if we don't modify it, it's evaluated on FUNCALL. Do we want that evaluation there? Do we want it evaluated on the scope of the FUNCALL, or do we want it evaluated on the scope of the curry? Like for other local variables, like if those change, if we evaluate it in the currying and that changes, do we want the value then, or do we want the value on FUNCALL?
That's what I'm going to get you right.
Okay.
Yeah.
So I don't quite follow why you quote the lambda. Okay, I understand why you quote the.
I did not quote the, oh, you mean, why did I quote the second lambda?
Yeah.
Because I want that lambda to be passed without the quote to the other function. I don't want that lambda evaluated.
So when do you want to evaluate that lambda?
That will be evaluated when I go in. So I've evaluated the lambda, I just want to pass that immediately to the function again. Right? The lambda.eval is not what I want. I want evaluation of the lambda expression to create the lambda. So I've got the lambda already. I don't want to call eval on it again. That returns something else if you go and look at your lambda evals. Okay, that lambda eval starts going and executing the body of the lambda in the new environment. So just like, in an atom's case, you can evaluate twice, it doesn't make a difference. In most S expressions, so in a non-lambda atom, A lambda atom, you know, when you take a lambda expression and you go and got to get a lambda, then when you do the second eval on the lambda, that starts executing the body of the lambda. I don't want that to happen. I want that to happen inside the function. So now let's, yeah. Sorry? No. Why not? I'm going to lose my recording. Okay, but I'll show it to you again. I'm going to trace it again. I did not quote the, when I went and, so should I quote which lambda? There are two lambdas. The lambda after the FUNCALL. Yeah. Did I quote the, should I have quoted the lambda after the FUNCALL? Your FUNCALL expects what? It expects either an ID as the next argument, or a lambda or a function. It doesn't expect a quote. That's how FUNCALL works. So I should not be quoting the lambda. FUNCALL, if you look at the FUNCALL structure, it expects either FUNCALL ID, it expects, sorry, FUNCALL expects something that will evaluate to a lambda or a function, or is a lambda or function. Let me put it that way. Okay. So actually, if you pass a quote, it would hurt because it will evaluate. If it doesn't evaluate, it will evaluate to the lambda. It will evaluate to the input lambda expression, not the evaluated lambda. So it will make a difference.
So the display in the previous slide is already stored as the evaluated lambda, right?
Yeah.
And then you put that evaluated lambda, which is a lambda atom, behind FUNCALL.
Yes.
But FUNCALL actually assumes something could be evaluated to this lambda atom, not the atom, lambda atom itself.
So this is the part that actually Andrew got wrong. He put the function name directly in. And I guess I got it wrong too. So you're right, it's already been evaluated. When we stored it in display, it was already evaluated. So we want to evaluate, we want to have a quote around it so that it doesn't get evaluated a second time. You're right. Okay. So I'll try to remember to fix that in the slides. Okay. So you guys got that? You all agree with that? That display already, when we did the set Q, we already evaluated the lambda, and we just discussed that we shouldn't evaluate the lambda twice. Okay, so FUNCALL expects something that evaluates to a lambda, and so we want the evaluated lambda to be quoted so that it doesn't get evaluated again. Okay. For the same reason we quoted the other lambda. Questions? Okay. Okay, now let's go and answer Robert's question. And we're also answering your question. Why don't you just put function there? Okay, and currying is something that C-Lisp doesn't provide. Okay, so this is something I'm doing in here to mimic ML. Okay, so that's part of the reason why we don't want to quite use function. So let's look at this. I have done display star result short, and I've assigned that to that a function, lambda xy, and I do FUNCALL display short output explanation product xy. Okay. I now go and set short output explanation to out after doing this set Q. Right? Now I do a FUNCALL display result short 2, 3. What will be output? Originally, short output explanation was result. When I went and defined the display result short, at that point, short output explanation was result. Now I changed it. Now I do a FUNCALL. What should be printed out, result or out, Chris?
It should be resolved, right? Because the function is supposed to copy the scope at the time that it's declared. That's the thing, right?
So Chris says it should be result because function is supposed to copy the scope. Anybody want to disagree with him?
Do a pointer to the environment.
So that is what you expect because of your instincts. But what we actually did was we just put a pointer. Okay? So in your assignment 4, we are going to give you an option. We're going to have an interpreter mode which says copy or not copy. And depending on the mode, you will do either. So there is a copy function environment. We put it there only for one reason, to sort of simulate the more intuitive one expression. This is exactly what ML does. Okay? So it'll actually be out. Okay? Now let's look at this. Okay, again, I'll have to go and put another quote here. What's going to happen here? Supposing I do set Q short explanation out afterwards, and then I do a FUNCALL display result short 2, 3, I'll get a auto result. Sorry?
Error.
Why error?
Because when you do the curry display short output explanation, that variable doesn't exist. The short output explanation. When you do the curry, you evaluate.
I'm assuming short auto explanation is already defined before result. Yeah, in all these cases, I'm assuming that we've already got that defined. So based on that, your logic, what am I going to get? So you can see what I actually got out here, right? You can see what lambda I stored. Modulo the code problem, this is the lambda we'll get. Okay, and what is stored is out, result. We've lost the variable name. Okay. So there is a difference.
So to be clear, is that the thing that you want? Like, is that what we want for Curry to do?
You have to become a language designer here. Okay. I'm taking Curry from ML. That's what it does.
This is what it does in ML.
In ML the environments are copied. So this is the ML semantics. Okay. And I think, intuitively, I have a feeling, at least Chris wanted that intuitively. And we guys, this is, so people talk of user interfaces and programming languages as if they're two different things. And people talk of user interfaces, when they talk of user interfaces, they talk of end users and think end users are a different breed than programmers, which probably they are. But a programming language is just a user interface to a programmer. And the question is, what is intuitive to them, what is not intuitive to them? And I think, binding yourself to an environment rather than a copy of the environment is, I think, more confusing. So I personally like the decision ML made. And ML came 15 years after Lisp. So maybe they knew better. But, in this course, I'm not getting so much into what we want as to what the choices are and what you might encounter in some language that you use. Okay? So it's more about, what the alternatives are and maybe what the pros and cons are in terms of expectations, but certainly how things would be implemented differently. Andrew?
Just to double check, what it would actually, it should be like FUNCALL.
Yes. You're just global substitution in your head at least, And I'll try to remember to do it. I'm pretty sure I will.
So function has an option to whether passing the pointer of environment or deep copy the environment, right?
That is an option that we have in our interpreter. Okay, we are not trying to do C Lisp. We are trying to do programming language concepts. So there is a bunch of settings which you haven't been exposed to, but they exist in the interpreter that says run it in this mode or run it in that mode. There will be one mode that says, I mean, Andrew and I discussed this. I believe he has it. I don't exactly know what call it is, where it will say please do the copy instead. And what I would like you guys to do is to write a function and execute it in both modes and show that the function returns different values in these two modes. Okay? That's the intellectual activity I want from that. So that you understand the effect of one or the other.
My question is, does the curry have the same options?
No, the curry has no option. We didn't put that option in. Okay? Yeah. We could add in another parameter. This is all going to be esoteric, by the way. So we can have fun and do lots of other things, but I think for now we'll just stick to this. Okay. Questions? Okay, I think I'll finish the rest of the stuff that I want today. So here's the difference. Free variables in function bound to the copy of the defining environment that exists at definition time, rather than the changing defining environment. So what are we binding the parameters to? In both cases, we want the defining environment. In one case, we just have a pointer to the defining environment. In one case, we have a copy of the defining environment. Okay. And this is a problem in Lisp because you can create new, well, I guess this problem exists also in Java. So I'll take back what I was going to say. Okay, actually I forgot, we go to the Curry evaluator too. Okay. And we'll have to fix this too based on what we need. So the Curry evaluator, I've got an input expression. I've got more or less the output expression we want without the quote. So what steps do we need to take here? I'm being told to curry a function. So I've got after curry a function, something that is either a function ID or it is evaluates to a function. And then we've got some supplied arguments, and we are supposed to do an s.eval on in a particular environment. So what are the various steps I need to take at this point? I'm returning back, let's look at what we're returning. We're returning back a lambda. How do we create a lambda? Okay, so the very last step is a lambda factory, okay, which needs curry lambda args and a curry lambda body. Now the question is, how do I get the curry lambda args? What I have is a bunch of expressions from E1 to En. Somehow they are used to derive the curry lambda args, right? So in this example here, I have result, and based on that I'm supposed to go and provide fxy. And how do I determine these variables? So in this case that happens to be f. So I should go and evaluate f, get the lambda, right? Get the arg names from that. Okay. So far so good. And now it's downhill. Curry lambda args are the ones that are have not been supplied. Okay, so we have A1 to AM are the ARG names. Some of them have been supplied. So whatever has not been supplied are the ARGs to my lambda. We are assuming M is less than N. Yeah. Or did I get the M and N wrong? Yeah. Should be N plus 1 to M? Yeah. Okay, so rather than AM plus 1 to N, it should be AN plus 1 to M. Okay, but basically you subtract and find the remaining arguments. Okay. So again, guys, I'll try to remember, but this should be N plus 1 and this should be M. Lambda body is, then you create a list, and it should be again quote F lambda, and then you go and say list, you create a list of quoted you take all the quoted, you take all the evaluated arguments, you put them in sublists, and those sublists are in a bigger list. Okay. And that list is the one that is then appended to AN plus 1. Oh, I got it right here? No, AN plus 1 to M, AM. Again, I got to change that there too. So you're taking your own parameters, you're taking the supplied arguments, you're making a list of them, and making a FUNCALL with that. Right? So the supplied arguments have to be always the initial arguments. You have to make your curry function in such a way that it's the initial arguments that people would want to curry with. And again, the M and N are switched here. So guys, if you're noting it down, just make sure you correct it down in your notes. Okay. And since I haven't implemented it, please look at this carefully. This may have some mistakes. Okay, we've already found 2 mistakes. Okay. This is exactly what we said before when we were talking about how curry works. Okay, so this is just formalizing that. Okay.
So we went over this in class and it's still extra credit just to add that now?
Sorry?
So now that we've gone over it in class, it's still extra credit on A3?
It's extra credit on A4.
On A4? Okay, well we can do it on A3 too.
Don't do it on A3. You can do it on A3. It won't be graded in A3.
Yeah, like,
So fine, you get graded in A4. You've just got few hours left till A3 is due. So that part is moved. We can't have the same extra credit be evaluated twice. It's got to be in one or the other. Okay? Good. Are you unhappy you've done? Sorry? You get it in A4. What's
Yeah, that's a reason. It didn't always say that.
I said it last Thursday. I said move to A4. Okay. So, okay, but I'm glad. I mean, you guys, it's better to be more relaxed later in the semester than less relaxed. And this list, I'm using a list function here that you'll have to use expression factory to go and actually create the expressions. Okay, tracing currying. Okay, I've got to put that code everywhere now. So you create. So we get this expression input expression. We go and quote the result, okay, and we are doing left to right evaluation. So we first quote the first argument, then we go and quote the second argument, okay, and add it as to the list we create the first argument. Then you go and get the unspecified parameters, okay, which are x and y, and you build a list. You combine the specified and unspecified parameters as FUNCALL parameters, as a list of FUNCALL parameters. I'm going through this a little quickly because we've got the idea. And you add FUNCALL of eval function, okay, and it should be add FUNCALL of quoted eval function, and you create the return lambda with unspecified parameters. Okay, so it's basically I actually fudged the trace I got from Andrew because he hadn't done the lambda evaluation, so that's where I made the mistake. Okay, we were looking at currying functions, and there were some issues in how to curry functions. So let's go and we'll get a little deeper into those issues today. But the basic idea is that you can, and we did this actually the last two classes, that you can apply a function with you can give some of the arguments of a function to it, and from that create a new function. Okay, so that's what we're doing here, and we've got okay, so we've got the function display, and we define curried display result short, and we that's a set queue, and that's assigned this particular curry operator here. Okay, and things have got complicated here because the curry is being called in a let. It's not being called in the global environment, it's being called in a let environment. Okay, so that brings into issues, brings scoping issues in, and lots of you guys, so we want to go and do static scoping where we resolve free variables in the currying environment. Okay, so we want display short output explanation to be bound to this value rather than this value. Okay, and we saw that we actually to do this we evaluated the results and quoted them. And one of the questions that was asked, and one of the solutions that was suggested before I gave the code solution, was why not just store the environment with the curry? Okay, and that's good. You guys are thinking in terms of storing environments. That's one of the big goals of this course, that you guys understand closures of functions. And so that was somebody suggested, that rather than so what we did was we actually evaluated and quoted the arguments and the function. Okay, that's what we did last time. And then the question arose, why not store lexical environment with generated lambda as an implicit function, and why do the coding? Okay, and I told you, it doesn't quite work, and so this is what was suggested. Why not just keep the variable names, don't quote them, and store a function? Okay, and what I said was, it doesn't quite work. I sort of figured it out, and this is before I'd gone for my trip, so I didn't give you the details. But the basic intuition was, okay, this is that if you're going to store them in an environment, then the actual arguments, so now the function that you're going to call display has got some arguments that were bound at the currying time, and some arguments that are bound at call time. Okay, and now they're going to be the ones that are specified at call time are in the local scope. Okay, and the ones that were specified at currying time are in this environment, which is this parent environment of the local scope. Okay, so now we have basically these two sets of arguments being treated differently, which they have to be because we are currying. But a consequence of this is that they are not in the same scope, and the curried arguments are in the parent scope. Okay, now they are in the environment, so you'll find them eventually, but some are in the local scope, some are in the parent scope. So that could cause problems, or that may not. And I told you, if you work it out, it does cause problems. And I'd forgotten how I'd worked it out. Okay. And maybe it doesn't. Maybe I didn't work it out right. So let's think about this. Is there a real problem here? So what I'm doing is I'm storing the actual names here. Okay, so we have this variable name, let's short out explanation, and I'm storing that here. I'm storing the actual name display, but I'm making a function binding so that I have access to an environment in which short output explanation is out, okay, and display is bound. So I do have access to an environment in which I don't lose the environment once I return this function. So I do have access to this particular variable. So why quote it? Why do this messy stuff? Why not just store the variable names with the environment? So when you have nested scopes, that's nice, right? You can just inherit the variables that are not in your scope. When do nested scopes cause problems? Have you guys ever had subtle problems because of nested scopes? Are there any warnings that are specific to nested scopes that you might get from the compiler? No? Yeah. When you use the same name. So if I use a name in a scope, the variable in the outer scope is now shadowed, no longer visible. Okay, and that's why sometimes you will get warnings saying, "Hey, you've got a variable shadowed. Be careful." Okay? Can you see some shadowing interfering with the semantics we want here? So we have two sets of arguments. We have the actual supplied arguments when the curried function is called, and then there was some arguments that were supplied when the curried function was defined. So one of these would have to shadow the other, right? Either the arguments supplied at call time shadow the ones that were supplied at curry definition time, or vice versa. Now we know that the arguments that are supplied at call time are the local ones. They can't be shadowed. So it must be the curried arguments that are shadowed at defined at curried time. So let me just give you the answer. So variables of parent scope can be shadowed, hidden by variables in children scopes with the same name. So what if I do this? So check all my slides, please. These they can be mistakes, but so what if I go and say let x be out and let y be lambda when I'm defining the curried function, and I say curry yx. Okay, I changed it from those long names to y and x because y and x are typical variable names. And because they're typical variable names, they've also been used in the definition of f. Okay, so what is my FUNCALL there? So my FUNCALL becomes yx fx, y. Actually, I did make a mistake. The f, there's no f there. Okay, so there's just yx xy. Okay, because I'm also redefining. Sorry. So this is FUNCALL, and this should be display, right? There should be somewhere, there should be a FUNCALL to display. So FUNCALL display, and then explanation becomes Y, and F becomes X. So that's right. I actually forgot the display here. And so it should be FUNCALL to display, and then YX FXY. Sorry. So this should have been lambda, since I've got both of these things and I've got 4 arguments here, this should be lambda xy. So again, this display takes 4 arguments, explanation fxy. So if I'm going to do FUNCALL, it should better be FUNCALL display with 4 arguments. And what I've done is I've curried yx, so I've supplied 2 of the arguments. And so the other 2 arguments are unbound. So that's why this is lambda xy. And this is display yx xy. Right? Is that right? Any mistakes here? So when you call display with when you call curried display result short with 2 arguments, those will be the y and x, right? So now, do you see the problem now? You're going to call the curried function with 2 arguments, x, and you'll supply values for x and y, and those will be used for the first 2 arguments too. The ones that you meant to actually be out and lambda, or rather lambda and out. Right? So curried actual arguments in currying scope have the same name as non-curried formal arguments in scope of curried function. So basically, we are sharing names, and the ones are provided at the parents. So the other values, the ones that you want, are in the parent scope, but they're not being looked because they got overshadowed. Okay? So we need to quote as a result, and so it does make sense. Okay? Questions? Okay. So that's one difference between function and quoting, storing the environment and quoting. And we saw another difference last time, and I'm just going to present it again. So if I go and say short output explanation result, and then I go and say, I go and I made the same mistake again. Okay, imagine this to be the x and y. Imagine this curried display result short to be just curried display output explanation. Forget the product here. Okay. So if I do that, and I go and set short explanation to out later, and I do a FUNCALL, I'll get this to be out, right? Because we bound it to the environment, so we haven't bound it to the copy of the environment. We bound it to the environment reference. So any changes you make to the variable afterwards are going to take effect. Okay, this is if we had gone and done a function. Okay, we had not quoted. Okay, we quote it. And again, imagine that I didn't have this product here, okay? And I go and set it to out. If I do this, we saw last time that we'll get result because we went and actually stored result, okay? So that's another difference we saw last time, that in one case, we are bound to a particular environment reference, in the other case, we are actually bound to the values. We've frozen the values at definition time. Okay, so this is what we did last time. So this is more like what happens in ML. Okay, in ML, the environment is frozen, and we don't actually, and lots of you guys were confused by this semantics in Lisp, because you expected the values to hold when the function was defined. So, what about implementing ML like state binding for functions?